All right, hopefully you did well on quiz 25. Go and turn your textbooks, if you would, to page 306, and if you would, get out your notes as well. I want to talk about a couple of things I've kind of referenced already as we've talked about lenses. And of course, we thought about glasses. I've referenced my glasses a number of times and the diverging lenses that I use. And there are a couple of key eye conditions that we want to address here as we talk about lenses, just so we get a good understanding of them. The first eye condition is called myopia, as opposed to europia. Myopia, M-Y-O-P-I-A. We see the prefix myo, and if you go back in your mind to health class, remember medical meanings? Let's see, I think this would have been Miss Morse. I think she was here at the time. She's not that recent. And so you had medical meanings in the side margin of your health book, and you were quizzed on them periodically. Things like osteo means bones, and ology means study of, and peri means surrounding, and myo. Do you remember what myo means? Refers to muscles. Muscles. Myopia? Muscles? Well, you realize as you study the human eye, and you might remember this from biology and from your health class, the human eye has at the front of it a hole that the light goes through. In fact, you can see it when I look into your eyes. Michael's is a little harder to see. He's got darker eyes than the rest of you. But the hole in the eye is called the pupil. Good job. Brownie points. And the light passes through the pupil. Now, before the light gets to the pupil, it passes through a clear covering over the eye. That clear covering is called the cornea. Okay, the clear covering is called the cornea. And then after light passes through the cornea, it passes through the pupil. Now, around the pupil, we have the colored part of the eye. Do you remember what we call that? The iris. Okay, the iris, of course, gets bigger and smaller to allow more light or less light through, right? Changing the aperture of the pupil, so to speak. And right behind the pupil is the lens of the eye. Now, you might have done this when you were a little kid, but you hold your hand really close to your face, and if you focus on that, everything behind it gets really blurry. You remember doing that when you were little? And as you pull the hand away from your face, the hand can remain in focus for a little while if you have good eyesight. My hand gets blurry right about here, okay? It's bad. Y'all all blurry, okay? But you've done that before when you were little and your eyes were actually good. You see, hey, I can focus on it close. I can focus on it far away, close, far away, and that kind of thing. Well, what's happening is your lens inside the eye has muscles attached to the end of it. And the muscles either contract and pull on the lens, and that squishy lens gets thinner. Or they relax and the lens is allowed to fatten out. As the lens fattens out, you remember the different lenses we used in class? Converging lenses. Remember the fat, squatty one? It focused light very quickly, remember? And then the thinner lenses focused light less quickly. Things that are really close have to be focused more quickly. They require a fatter lens, and the muscles are allowed to relax, and the lens is allowed to get a little more squatty. And then as you look at something further away, the lens has to pull tighter, thinner, to focus light that's further away. The problem is, if the muscles can't pull hard enough, so to speak, to allow the lens to focus the light, we get what's called myopia, hence the name. Really, though, it's not caused by weak eye muscles. That's not really the cause of it, but that's kind of the thought is the muscles can't sufficiently thin out the lens enough for objects that are far enough away. Really, myopia, by the way, we do need to know this is nearsightedness. Nearsightedness, meaning you can see things that are near just fine, you just can't see things further away. For instance, I have this bad habit of looking, maybe at nighttime. You don't want to put my glasses on, but I'm looking at my phone or maybe the Chromebook for just a second. I want to look something up real quick before bed, and so I'll have my glasses off. And so as long as my textbook is here, I can read it just fine. It's kind of sad, isn't it? Out here, it's blurry. If I squint, I can make some heads or tails of it a little bit. And out here, I've got no chance, okay? Now, with my glasses like this, I can actually read words on Kendall's book, which is about 3 feet away, okay? The idea is I can't see things that are far away, but things that are close up I can focus. There's a couple causes for myopia. For one of them, it could be that the cornea of the eye is too curved. the cornea of the eye is too curved. Okay, the cornea is supposed to have a certain curvature to it, but if the cornea's curvature is too great, then that would cause problems. Contact lenses can correct this a little bit specifically because you put the contact lens directly on the cornea, and that in a sense reshapes the cornea, so to speak. Not really reshapes it, but comparative, when you put the cornea and the lens together, it performs the reshaping that you need. And so the cornea being too curved, because that's the first surface that the light hits, it can cause the light rays to start to converge too quickly. Also, again, as I said, the eyeball, if the lens of the eye isn't thin enough, it causes the light to converge too quickly. The back of the eye is where rod and cone cells are. Remember learning about those? Rod cells detect light and cone cells detect color. Colorblind person, their cone cells aren't working properly. And so that's on the back of the eye called the retina. Remember, the retina is the back of the eye. Y'all don't remember too much. That's not a good thing. You're supposed to not forget anything. Remember? Not allowed to forget anything. Oh, okay. Anyway, I won't tell Miss Morris. Now, it's on camera now, but I won't tell her. All right, so anyway, the light is supposed to focus on the retina so that the retinal cells can then send the message to the optic nerve sends the message to the brain, and brain tells you what you're seeing. Well, the problem is if the light focuses too quickly, you look at the figure 20.29b. You see how the light rays are focused and it's not all the way back to the retina yet? That's a person with myopia. And oftentimes, this is more a hereditary thing. Maybe it's not that the cornea is too curved. Maybe it's that the eyeball is too long or too deep, is maybe a better way to think of it. So that the light rays converge where on a healthy, normal eye, that they converge right where the retina is. It's not really a problem with the lens or the muscles of the eye. It's just, but if the eyeball's too deep, then the light rays have already focused somewhere in the vitreous humor, that liquid inside the eye, which means, you know this, the light rays converge and then they spread back out again. Well, they're back to spread out again by the time you see it. And so we kind of see what we saw on that page. Remember that poster? When we could tell, okay, there's the leprechaun, or there's the hall pass, or there's my name, but it's not focused very well. The light wasn't focused yet, and so we get a blurred image. So the eyeball being too deep, or potentially the cornea being too curved, either of these can cause nearsightedness. The ultimate problem, though, is the light focuses too soon. The light focuses too soon. It focuses before it hits the retina. That's the key. So if the light rays are converging too soon, we need to find a way, here's the key, to slow down their convergence. Does that make sense? Light rays from the back of the room back there, they're converging too soon. I need to find a way to slow down their convergence. So you know what I could do? If I could cause them to spread outward a little bit before they ever get to my lens, they'll already be going outward. And then the lens brings them together and they focus perfectly at the retina. Does that make sense? Because light focuses too soon, you use a diverging lens to correct myopia. It causes the light rays to spread outward just a little bit so that when they hit the lens of the eye, they're on their way out. They're not parallel anymore. They're going outward. The lens first has to correct the outwardness and then focus them from there, causing them to focus, if you have the right strength of lens, causing them to perfectly focus on the retina. Does that make sense? The flip side of myopia would be hyperopia. Hyperopia. Hyper meaning above or beyond what is normal. This is a person who, if there's light rays far away, they may be able to see someone at the back of the room just fine, but as soon as you put a book in front of their face, like, whoa, what? And they're almost holding stuff away because they can't focus on things too closely. Some people with hyperopia, they can't focus on anything. Like all light is blurry to them. But hyperopia is typically the name for farsightedness. Again, in some cases, a person with hyperopia, they can't focus on anything near or far. But hyperopia, generally we think of it as farsightedness, meaning you can't focus on things that are very close to you. This could be caused by the cornea being too flat, not enough curvature, or more frequently, hyperopia is caused by an eyeball that is too short or too shallow. So the idea is this, that light rays that are far away, as they go through the lens is relaxed, the light focuses to the retina, and we're okay. But things that are in closer, those light rays as they're starting out closer, because they're kind of spreading outward on their own, they can't focus quickly enough, and so light would focus behind the retina. Well, that's no good, right? Just like when we had the poster too close, we said, let's back it up a little bit. The light wasn't focused yet. It's on its way to focusing, but it's not actually fully focused by the time it hits the retina. Again, especially when the eyeball's too short, you see a picture there of where the light rays would converge, but they're behind the retina. A person then with hyperopia needs help focusing light more quickly. Does that make sense? If it doesn't focus quickly enough, it focuses behind the retina or would focus back there, we need to start focusing the light before it gets to the eyeball's own lens. So a converging lens brings light rays together a little bit before they ever get to the eyeball's lens. The eyeball's lens finishes the focus on the retina, and things that are close up they can see. So a converging lens is used to correct hyperopia. Now, of course, you have astigmatisms and things like that where you've got, misshapen cornea. Okay, that takes a prismatic lens, and there's different things they can do for those. But as far as the lenses that we deal with, there's just converging and diverging lenses. Myopia, hyperopia can be corrected by those things. Now, when you go to the eye doctor, they check and see how bad are your eyes. How deep is your eye? The deeper the eye, the more strongly you need those lenses to divert, the diverging lens, to cause the light rays to spread out even more, so that by the time they get to your lens, they're able to focus way back there. Or maybe it's not super deep. Maybe it's only a little bit deep. Maybe the cornea is only a little misshapen. They test and see how bad your eye is, and then they assign you a lens from there. And they give you your prescription in what are called diopters. And we'll talk about the power of a lens and diopters in our next lesson, since we are out of time. Your homework for this evening is to read pages 305 to 307. Read pages 305 to 307. And on page 307, answer questions 18 to 21. And I just realized I was off camera this whole time. Oh well, the board was on camera. That's what matters. All right, page 305 to 307. On page 307, answer questions 18 through 21. We'll begin using the thin lens equation in our next lesson, then wrap up this discussion of corrected lenses. Have a wonderful rest of your day, and you are dismissed.